I would like to request Dr. Tapas Samanta, Public Awareness Cell Chairman and also Senior Scientist, to give the welcome address.
Good afternoon. Welcome you all to this celebration of National Science Day at VECC. Because of this pandemic, as told by Ranjini, we are organizing this online. And the main theme of National Science Day celebration of this year is integrated approach in science and technology for sustainable future. So before getting into that, I just want to give a brief about this National Science Day. In the year 1986, National Council for Science and Technology Communication proposed to celebrate this February 20th as a National Science Day. This February 20th is a very special day for us because on this day, the Raman effect was discovered by scientist, basically Nobel laureate, Dr. C.V. Raman. And this particular effect is called Raman effect, where we know that when a laser light is falls on a particular component or compound, it gets scattered. So normally you get a Rayleigh scattering, but very small amount of light gets scattered in a different way. It's called inelastic scattering. And there actually the component characteristic scattering takes place. So using this, we can identify different characteristics of the particular compound, and that's why it's called Raman spectroscopy. So that was the main event, and to mark that, we for this also he got the Nobel Prize. So that's why we want to mark this event as a special day and to acknowledge the contribution of scientists for the development of the country. So that's why Government of India in 1987 onwards celebrating this one as a National Science Day. So this year also we have organized this one like previous years as a part of our public awareness activities. We are participating in this one. There will be details event as you have seen in the schedule. Already have got it. So I will not take much time. I'll now pass on this to our coordinator Ranjini for the next event.
Thank you so much, sir. Now I would like to request our respected director.
Yes. Thank you, Ranjini. Good afternoon to all students and teachers connected online, dear colleagues, ladies and gentlemen. On behalf of VECC, I extend my heartiest greetings and warm welcome to you all in this year's celebration of National Science Day at VECC. As you all know, National Science Day is celebrated in India on 28 February every year to commemorate the discovery of Raman effect, already told by my previous speakers, by the great Indian physicist and Nobel laureate Sir C.V. Raman on 28 February 1928, and he was awarded Nobel Prize for Physics in 1930 for this discovery. The theme, as Tapas has already mentioned, the theme of this National Science Day is integrated approach in science and technology for sustainable future. Science is critical to tackle complex challenges for humanity, such as climate change, biodiversity loss, pollution, and poverty alleviation, as it lays the foundation for new approaches and solutions. For example, carbon capture and storage system, efficient irrigation methods, essential medicines, manufacturing processes that minimize waste and pollution. Transforming scientific breakthroughs into new technologies can have a profound impact on development, but wise approach in application of these technologies is essential so that the balances are maintained in productivity with long-term resource viability. As you know, VECC is a premier R&D organization under the Department of Atomic Energy, Government of India. We mainly do research on science and technology of particle accelerator like cyclotron, its application in nuclear physics, production of radioisotopes for the diagnosis of cancers, computer informatics, material science, mechanical engineering, advanced mechanical engineering, cryogenics, electronics, theoretical nuclear physics, high energy physics, and many other branches of science as well. We must understand that we will have sustainable future if and only if we have integrated approach on research and development of basic sciences and technologies as well. That means the science of today is the technology of tomorrow. Through this National Science Day celebration, our aim is to promote active involvement of students and teachers in science-related activities, encourage the students to ask questions during interactive session and to get their doubts cleared in different areas of science and technology, and enable the students to know about the latest development in the field of science and technology. With this brief overview, I would like to conclude my speech with a quote from Sir C.V. Raman. Quote, "It is generally believed that it is the students who derive benefit by working under the guidance of a professor. In reality, the professor benefits equally by his association with gifted students working under him." So happy Science Day. Thank you all. Jai Hind. Ranjini, you are muted, I think.
Am I audible now?
Yes.
Yes. Thank you so much, sir, for elaborating on the theme of this year's National Science Day celebration. And we shall move on to the next program. A virtual tour on Variable Energy Cyclotron Center. You will be having a small video show on VECC. I hope you all have enjoyed the virtual tour of Variable Energy Cyclotron Center. In fact, you can all come here physically, visit. You can have a half-day program here. There is a provision to do that. You may please contact your teachers if you would like to come over here. We request, we encourage all the students to come and have a tour here. That is possible. And one announcement is there. The students, those who have applied for the debate participation today, please type in the chat box whether you are going to speak for or against. You may just type for or against. And today's topic, if you still want to get reminded, technology rather than science will drive to sustainable future. Today's debate topic is technology rather than science will drive to sustainable future. We shall move on with the program. So we will be having a lecture by Dr. Amit Roy. It's my extreme pleasure to introduce Dr. Amit Roy. Dr. Amit Roy is a eminent scientist and has enormous contribution to the particle accelerator facilities of India. He holds a PhD from Tata Institute of Fundamental Research, Mumbai, and there he continued as associate professor for a few years. He spent 2 years at Florida State University, USA as a postdoctoral fellow and has worked at KVI, Netherlands and Argonne National Laboratory, USA as visiting scientist. Later, he joined Inter-University Accelerator Center, New Delhi as a senior scientist. He was its director from 2001 till July 2013. He was DAE Raja Ramanna Fellow at Variable Energy Cyclotron Center, Kolkata till May 2017. Currently, he is a guest lecturer at Indian Association for the Cultivation of Science, Kolkata. And also he serves as an advisor to Manipal Institute of Natural Sciences. He is a fellow of the National Academy of Sciences, India, and received the Eminent Scientist Award of the Indian Nuclear Society. He has served as President of Indian Cryogenic Council, Chairman of Asian Committee of Future Accelerators, member of International Committee for Future Accelerators, and as a member of Nuclear Physics Working Group. Let us welcome Dr. Amit Roy for the speech. The topic is Nuclear Science and Technology for a Sustainable Future. Sir, please.
Thank you, Ranjini. Thank you, and giving me the opportunity to talk to you all and the students, especially the students. It gives me always a great pleasure to talk to students, and I do not normally miss an opportunity to talk. Or it would have been nicer if I could be present physically with the students, but then hopefully in the near future, such opportunities will arise once the pandemic goes down. So nevertheless, this also allows me to speak from a distance, because I'm now sitting in Delhi, and I'll be able to at least give this talk to the students through this video conferencing. So let me start sharing my slide presentations. So I shall do that. Are you able to see my screen?
Yes, sir.
Okay. Let me put it on the slideshow mode. Yes. So the topic, as is part of the today's program, is in science and technology, integrated science and technology for sustainable future. And since my area, I am familiar with the nuclear science and technology to a little extent. So I'll try to share you my view of this particular area of science and technology for sustainable future. So why do we do science at all? First of all, see, it's a part of study as a part of human nature. That is the nature of it. Our human beings are very curious. We are curious beings, and our curiosity has given us all the knowledge, and the knowledge has led to progress, right? From the very prehistoric times to what we are now today. We are enjoying so many facilities which we are able to get from nature. But then this pursuit of this science being a purely academic and intrinsic personal experience does always lead to, most of the times leads to some technological benefits, and that's what we will be talking about today. Now, if you really look at the earlier days, the primitives, our Indian culture, and also the indigenous cultures of the world, they had all the development that they thought of was also part of nature. And then there's a holistic view of nature, that we are part of it and we must protect the nature also, along with using the natural laws for our advantage. But from this present 300 years, the march of modern science has changed, the Western perspective has changed that thing. And it has been about exploiting nature rather than being in synergy with nature. And that is what has caused many of the problems that we see today. We'll talk about that a little later. But the technological benefit that we have derived from the search for knowledge through science, pursuing science, are many examples about. Every day we come across we use the benefits of doing science in the form of technology. We have electricity, we have telephone, we have transport, we have GPS, global positioning system, we have the internet, without which this particular video conference wouldn't have been possible at all. And we see the impact of science at it and its result, which is technology. And the practice of science also trains people to think in a logical and objective way independently. These persons are valuable assets for any society for its progress. So now we come to the sustainable future. As I said, that we have to be in synergy with nature, and sustainable future has been defined in the United Nations report as development that meets the needs of the present moment, without compromising the ability of future generations to meet their own needs. That means today I must not exploit and take things for granted for myself and forget about what's going to happen to in the future. We must leave enough resources, enough possibilities of the future generations to live as well, if not better than us. And United Nations had formed these goals, sustainable development goals, in 2017, and there are 17 goals are there. You can see it on the screen, and I'll read it out if you're not able to read them. First is no poverty. Second is zero hunger. Third is good health and well-being. Fourth is quality education. Fifth is gender equality. Sixth is clean water and sanitation. Seventh is affordable clean energy. Eighth is decent work and economic growth. Ninth is industry and innovation. Reduced inequalities, sustainable cities and communities, responsible consumption and production, climate action, life below water, life on land, peace, justice, and strong institutions, partnerships for the goals. These are the 17 goals set by the United Nations for sustainable development. So this envision a world where people are fed, healthy, employed, educated, empowered, and thriving, and where all other life persists. That means we are doing it, it's a kind of synergistic, holistic idea of development, that everybody gains. No person, no part of nature, no living beings and environment, it's disturbed to that extent that it is destroyed. Now, science and technology can address some of these goals, not all of them, because as you've seen, some of the goals come more with to do with the social structures and the political system. That, for example, access to food security for all, we can look at science and technology can address some challenges. It can improve the food production. It can make food more available to people, but then the distribution part of it, to make it reach everyone, is a goal of the society as a whole. It's not the scientists alone cannot do that. Scientists or technologists cannot do that alone. They have to be, the entire social system and the politicians, the government has to go together for doing that. Same thing with health security. Again, science and technology can give us better medicines, better technologies for diagnosis, better therapies, systems, and so on. But again, distributing it all over the globe, all the countries of the world, and to everyone in the country also, it's a goal of the whole society. Same is the education for all, but science technology can address the certain parts of it, make it easier to access education. Addressing global warming and climate change, this is one of the very serious problems today. In fact, today itself, you have seen in the newspapers that yesterday, the Intergovernment Panel for Climate Change had given their report, and it says that already the climate change which is on us, and it is to some extent irreversible, and it is going to cause lots of damages for the entire ecosystem. And then industry and development for all. There also science, of course, can help in producing better, make industry more efficient and more employable. So the global warming and climate change that we have heard and read today also in the newspaper, it says that if you take the temperature rise that takes place on the Earth, the entire ocean temperature goes up. If it goes up by 1.5 degrees, which was agreed in the Kyoto Agreement, that would have already affected so many millions of people in different aspects. That is, water stress, lack of water, heat wave exposure, risk to power generation, crop yield, habitat degradation. And you see that up to 2 degrees, right now the scenario is that we will not be able to keep the temperature down to 1.5 degrees. Doesn't look possible because the way people have not given up their habits, or we have not been able to find better technologies to solve this problem. We will be ending up with at least 2 degrees centigrade. That is the now presently stated goal of all the nations together. In the last year, they met in Glasgow and discussed that they will try to keep the temperature rise below 2 degrees. But even then, you find that so many people will be affected, so many millions of people will be affected, and most of the people that will be affected are in the tropical region, and our country will be one of the major affected region of the world by this climate change. Now, why this climate change has taking place? Basically, I'll like to point out this particular figure here, which is a human development index, which is connected with the per capita primary power consumption. Let's say electricity, kilowatt per person. Now, if you see that all the countries which are advanced nations where the life is much better, the human development index has been defined in the United Nations as comprising of 3 things: health, education, and living standards. That means life expectancy at birth. If you have proper good health systems, then you have high life expectancy at birth. Then you have a good education system. Then you have many years of schooling and the number of schooling years that you have in the country, and then the gross national income per capita. These 3 things define the development index, and one is supposed to be the highest. Now, you see that the consumption of energy, that is, let's say electricity here, per person per capita, if it saturates, it increases very sharply as the power consumption increases, and then it goes sort of smoothens out and then almost flattens here. So you need to have a good standard of living, to have a good life. You need to have at least 4 kilowatts of power per capita. Now, many of the countries of the world are not having that, and so obviously everybody aspires for a better life. And so in our country, also India, we are right here, down here, pretty low in the human development index. So we have to generate power. So when you generate power, the total power generated in the world today is given in these slides as a function of time in form. It has been given, and it's going up and up and up. And we find that this electricity generation or power generation comes mainly from the fossil fuels like petroleum and other liquids, natural gas and coal, whereas renewables are only 11.1% and the nuclear is 4.3%. So the major part comes from the fossil fuels, which generate carbon dioxide. This carbon dioxide goes and sits in the atmosphere, and then it lets the radiation from the sun come in, and when it gets the part of the sun which is absorbs it and then re-emits it in a lower energy, that's infrared radiation. The sun's rays comes in certain wavelengths and goes back in higher wavelengths. These higher wavelengths infrared are absorbed by this carbon dioxide, doesn't let it pass through, and doesn't let the earth cool. That is why the global warming is taking place. So these are called the greenhouse gases, carbon dioxide, methane, and this kind of gases. And the industrial processes, our power generation processes has been generating a lot of these greenhouse gases, and that's why the temperature of the earth is rising. Now, so the only way is to change over slowly from these fossil fuels to the renewable fuels, which are solar, wind, hydro, biofuels, geo, tidal, etc., and nuclear. Because these are the clean fuels, the amount of carbon dioxide generated is much, much lower than in the fossil fuels in the process. So if you see this particular graph, it tells you the grams of carbon dioxide equivalent per kilowatt generated of electricity, and you see that coal, gas, they dominate in generation of carbon dioxide, but even hydro and solar does emit a little bit, but much less compared to those. And you see the wind and nuclear are very much lower. So these are the cleanest ones of all the power generation methods, generation of electricity. So we have to go into that area of this solar power generation and the nuclear. So I will not go into the other areas because there are a lot of work also being done in the solar and wind. And in fact, it's in India, it's quite a substantial portion. We are building up the solar capacity quite rapidly with putting solar cells. But then there's photovoltaic cells. There's a lot of work to be done further for research and technology available. There is enough scope to improve the efficiency of those devices, and that hopefully in the future things will the more and more solar energy will be used for making electricity. In the meantime, we need to have this. We have to use the fossil fuels to some extent, try to reduce the carbon impact of it by many other chemical means and other absorption techniques, and also use nuclear energy, because that provides a steady energy. Wind and solar are not available at the same level every minute of the day, every hour of the day. Solar, for example, is only 12 hours you get a higher power generated, and the night you don't have solar power. Wind, during the time the wind blows, you have power generated, and the wind speed is variable, so you got variable speed. But many of the processes that we are using require energy at a steady rate. So we have to use some of the fossil fuels and nuclear. Now, nuclear power you have two types of power, fission and fusion, and the fuel uranium for the fission power is abundant, and technologies for converting exist fully. We have a very concentrated source of energy generation. You need, and 1 gram of uranium is equivalent to 3 truckloads of coal, for example, for generating electricity. Waste is also more compact than any other source, and there are no greenhouse or acid rain effects. Of course, there is a large capital cost in it, and radioactive wastes are generated, which can also be transmuted. And possibilities of research is going on right now in our country, as well as many other countries of the world, to how to convert this radioactive waste into less harmful ones. Now, so new designs of compact reactors also been designed, which will have much lower footprint and also easier to build and lower capital cost. We right now have 23 operable nuclear reactors in India, with producing about 6.9 gigawatts of power, and nuclear was 3.3% of the country's electricity. World production is 2,692 terawatt hours. So this is, and in fact, I make a case here that the nuclear power should be increased, the amount of power generated from nuclear, because it's a much better non-greenhouse, so not greenhouse gas producing energy source. The fusion reaction, that's of course once it starts by fusing two isotopes of hydrogen to generate energy, and it produces very little radioactivity. It just produces certain neutrons and alpha particles, which are alpha particles are helium nucleus, and then this can be all absorbed and used for its energy generation, and the energy with it can be converted into power, electric power. But the problem is that to confine this to let this deuterium and tritium come together to execute this reaction is not easy, because these have got the positive charge. The nuclei of both of these are positively charged, and so they repel each other. And so you have to give them energy, make them energized. Energy is them enough so that they can overcome this repulsion, the charge repulsion. So that means the temperature has to be very high. This happens in the sun naturally. In the core of the sun, the temperature is 20 million degrees Celsius. And there the deuterium and the protons, actually protons and deuterons, all these isotopes are moving at very, very high speeds, and they can combine together to produce to fuse together, and 4 protons gets converted into alpha particle helium. And in the sun, every second, about 4 million tons of hydrogen is getting converted fused into helium, generating the energy, tremendous amount of energy from the sun, and we are getting only very small percentage of it, and that runs entire living systems, and the even weather and the plants and all of us, all the life on the earth is supported by that small power. So sun is actually a fusion reactor in the space, sitting there in space, but we'd like to duplicate that, replicate a mini sun on the earth, and there is an international effort going on right now. International Thermonuclear Experimental Reactor with 7 kind of partners: European Union, India, Japan, China, Russia, South Korea, and United States, all chipping in together. We are footing about 10%, approximately 10% of the cost in kind. That means we are making the thing here and then taking it to the site, which is at France, in Cadarache, a place called Cadarache, where it's being built right now. We have supplied already the main vessel, which is something like 30 meters in diameter and about 20 meters in height. And that vessel will be a cryogenic vessel. You have seen the picture of these. You have the superconducting cyclotron that has a cryostat, a vessel where liquid helium is kept. And this is also another type of cryostat where they will be filled with liquid helium, and then will be large magnets, superconducting magnets, which produces a magnetic field, and the deuterium and tritium in the form of ionized gases will be moving inside, and then they'll be heated to the temperature of 10 to the power 8 degrees Kelvin or so, 8 degrees, 10 to the power 8 degrees, 20 to 100 million degrees Celsius, in that range, and so that they can fuse. So the idea is that you generate power more than what you are putting in. And this has not been achieved yet, but this ITER experiment, a joint experiment with the international one, aiming to achieve this generation of extra power than we are putting in. And this is already is being built, and it will be the first experiment probably will be done somewhere between 2028 and 2030. So all of you, which are students who are here, will may be able to participate in some of these experiments as well, if you take this, if you join this kind of effort. So now I'll come to the how the knowledge gained in doing nuclear sciences and the technological progress that are there can be used to benefit society. You have seen in the virtual tour of the center of the cyclotron center, many instruments that are there. Many of you have seen the particle accelerators, which accelerate charged particles, the nuclei of charge or the charged particle, the positive ions, to very high energies, hundreds of MeVs, million electron volts. That means they are at that velocity, at that energy, they are moving very fast, close to 10% of velocity of light, sometimes 20% of velocity of light. And this kind of it is mainly to do basic research in nuclear, to understand nuclear physics. And we have, of course, access to even higher energy machines which are abroad, which is like at CERN, the Large Hadron Collider, which accelerates protons to 7 tera electron volts to find the structure of what is inside the protons and what is inside the even smaller substructures of the matter. And so that's the high energy physics. So nuclear and particle physics uses these kind of techniques. And to do that, we need to have these machines, build these machines. So a lot of technologies are developed for this purpose. And then the detector systems you also seen, there are also a lot of new technologies are developed to understand how to catch the radiation, use the radiation, and so on. And these technologies can be used for benefit of society. And the areas I have written down here are can be used for food preservation, sterilization, in agriculture, medical diagnostics and therapy, material processing, and tracking climate change, and of course, clean energy of the nucleus, fission, which I've already covered. Now, tracing techniques which are used, they were generated by George Hepse, a Hungarian physicist, in 1911, and he was working in England, Cambridge. So the story of this, he used lead tracers absorbed by plants to see the movement of the nutrients in plants. And for this tracing technique, he got the Nobel Prize in 1943 and also Atmospheric Peace Award in 1959. And incidentally, he also discovered the element called hafnium. Now, the story is there's a story associated with him that he was staying as a paying guest in an old lady's house in England while he was doing his work, PhD work, and he used to get food for the lady used to cook food for him, and then he suspected that the lady was using the leftovers many times. So what he did was he brought a little bit of radioactive sample from his lab and then put it in after he's finished, the leftover, he put a little bit of it. And so next time when this same food appeared, he could pick it up with his counters, with the radiation counters. So this cartoon says that. I don't know whether it's really true or not, but this is the story told about Hepse. That's how he found out. That gave him the idea that this can be used. Radioactivity can be used for tracing various things. Like this can be done for smog formation, sulfur dioxide in nature, contamination, sewage disposal, water flow measurements, etc. This was about 3 years back in India. There was a group from BRC and Uttarakhand University in Uttarakhand. They studied. They found that in the area of mountain area of Chamoli district in Uttarakhand, the one spring or river was coming in, and it just vanished somewhere into the earth, into the hills. So by tracing, using the radioactive nuclei, they could trace the movement of the water and found out some other place where radioactivity is coming, and then they dug that place and the water came out. So they recharged the spring. And the radioactive tracer, for example, close to your place in Calcutta, Hooghly River, the silt studies movement is studied through using radiation techniques. Gamma radiation kills bacteria. Electron radiation also kills bacteria, and without affecting the nutritional value of foods. Irradiation food doesn't make it radioactive. And we have the Atomic Energy, Department of Atomic Energy has a program for doing this irradiation, and it has set up many places for food irradiation at defense like Jodhpur, in Trombay, Navi Mumbai, and Lasalgaon, Indore. In fact, in Indore, in a vegetable market, this irradiation facility will be put up, and where the vegetables and the other things can be there, and it stays much longer because bacteria are all killed without spoiling the food. They can last much longer. Shelf life goes up, and so it will be good. It's a good boon for the vegetable distribution system. Now, in medicine, we have the nuclear techniques help in drug discovery, help in diagnosis of diseases and therapy. For example, you have heard, we have been all affected by the COVID, the pandemic, and this, the particular SARS-CoV-2 virus, that structure was determined through using transmission electron microscopy. And transmission microscope uses a high energy beam of electrons to take pictures of these biological objects. This particular technique was discovered a few years ago by the TEM, cryo transmission electron microscopy, which gives very good, very sharp, and very high resolution pictures. And with that, they found out the structure, that it's like a corona. The structure is there, and the spike protein, as you can see here. And the structure, the actual spike protein, the whole structure along the entire thing was determined using synchrotron radiation. This is a radiation coming out of a large electron accelerator. So, of course, this actual experiment was done in Argonne National Laboratory in USA. But in our country, in India, we have a similar synchrotron at RRCAT, Indore, Rajaramana Center for Advanced Technology, Indore, where the 2.5 GeV electrons are moving around in this ring, and then tangentially the beam, the X-rays come out of it, and these X-rays can be used for determining protein structure. And so this is a great boon for drug discovery, because once you think of a drug and you think of a structure chemically, the molecular structure, then to make sure that it actually conforms to that, you can prepare a drug through your chemistry, and then you can check whether the structure is exactly what you thought would be, and by going to the synchrotron. So at Indore, we have a beam line which can do these kind of things, find out the structure of proteins, which are being used by many people in molecular biology. We have also at VECC, we has a medical cyclotron which produces isotopes. This is dedicated one. We have a 30 MeV medical cyclotron. It's producing, for example, the fluorine-18 isotopes, which are used for PET scanning, and doing diagnostics. And the positron emission tomography, the fluorine-18 emits two positron, is a radioactive nucleus. It is created in the cyclotron, and it emits positron, which then emits an electron, which is there in any material, and it'll, as soon as it emits an electron, it annihilates into two photons, two gamma rays, 511 keV of energy each, which goes in the opposite direction. So if you inject in a body this fluorine in the form of a glucose, FD, which is called FD glucose, fluorinated glucose, and that glucose will be going into a tumor, which is, tumors are always more active, and so they will uptake the sugar, the glucose more. And so at that point, the emission will take place. And since two gamma rays are there, by looking at the gamma rays, putting an array of gamma detectors, like you've seen in the VECC tool, which is used for studying actual nuclear decays. We do it for understanding the structure of the nucleus. Similar kind of detector arrays are used here to find out with the position where from this gamma rays came. And so you can diagnose the size, find the size of the tumor, where the tumor is actually. Not only that, you can find out the brain in action also. For example, hearing what if you use this radiation radioactive nuclei stressor, the positron emitter stressors are there. The PET scans will tell you when you're hearing which part of the brain gets activated. so that you can be found out. So you can identify different regions of the brain. So you can start do for the neurologist is a great boon to find out how the brain works. The application of the magnets, you have seen in the VECC, there is a superconducting cyclotron which uses superconducting magnets. And these superconducting magnets were actually built for the particle accelerators first. This was done, of course, in the USA, in Fermilab at the Chicago. There is a big accelerator center, Fermi National Laboratory. There, they had first built such big superconducting magnets, and then that technology has been used to make magnets for the magnetic resonance imaging, which is, and if you walk to today in any hospital in Kolkata, you will find in a big hospital in Kolkata, there will be an MRI machine, and which will be having the magnets will be having of the order of 1.5 Tesla, means 15,000 Gauss, or some places which are better, more super specialty hospitals will have 3 Tesla, I mean 30,000 Gauss field generated. And so the scanning can be done, and identification of the imaging of the disease or tissues can be done. And in fact, there is now a project taken up by the Ministry of Information Technology and Science. The IUAC, the place which I was earlier there, Interuniversity Accelerator Center in Delhi, they have taken up a project jointly with part of the work also is being done in VECC and Kolkata, as well as in Samir, and which is microwave engineering group, and they are making this magnet for making a MRI magnet in the country for the first time, indigenously made, and 1.5 Tesla. This particular one shows the picture of that, which is wound. Radiation therapy we have with electron LINAC. Most of the hospitals now have electron LINAC, which are electron accelerators, few MeV, few mega electron volts electrons, which then emits strikes a target and produces X-rays of very high energy, and this can be used for both diagnosis as well as therapy for treating cancers. And then the boron neutron capture therapy also use neutrons to treat cancer. And directly ion beam, very high energy charged particle beams can also be used for treating tumors. This is a very promising technology, and which has got very little side effects compared to the other forms of radiation therapy. And in the country, there is one is planned at Tata Memorial Center, Mumbai, and at Apollo hospitals in Chennai. We can use the accelerator techniques, which is nuclear technique, for ion beams, for milling, for making MEMS devices. We can use for lithography, for doing in semiconductor industry, for making various multi-layered semiconductors, etc. So such industrial applications and many other industrial applications which I will not go to, because that will be another whole set of whole lecture itself. We can use the radioactive carbon, which is there formed in the nature, trace this carbon-14 through radioactive decay or through accelerator mass spectrometry, which is a very high sensitivity, 1 in 10 to the power 15. That means you can detect one carbon-14 in the presence of 10 to the power 15 normal carbon-12 atoms. So it gives unprecedented precision to find out things, and this can be used to study the oceanic circulation, how the ocean circulation is taking place, and so that how the global temperature variation is taking place in the oceans, and so you can track the global warming. You can even track through ice cores in the Antarctica. You can find out what the climate was millions of years ago. So how these things have changed over the millions of years, and that can give an understanding of our climate. The internet that we are using every day, the World Wide Web, that was actually discovered by an accelerator scientist, Tim Berners-Lee at CERN, and this is the machine which he used at CERN to set up the first web at Geneva, and this was done for the communicating the data as well as these papers that were the energy physicists were writing and doing experiments, because they were sitting in, the participants at CERN are international. I mean, they come from more than 150 laboratories, 200 laboratories in almost some 30 countries. So they are spread all over the globe, and they have to communicate their results. And today, because of this, people, our Indian scientists, researchers, can sit in Mumbai at TIFR or at Kolkata in VECC and work on the CERN system. And they can take data from CERN sitting here in India and then also analyze them. We have IUAC, which I tried with the nuclear technology, detection technologies and the electronics development that we had. We thought that we will try to do something for the school experiments, and we did that. One of my colleagues in Delhi, he developed a system called Xpise Experiment for young engineers and scientists developed. And this is to improve the accuracy of existing experiments, redesigning them using the low-cost interface. This is the interface where you can connect any detector system, and this works as a completely data acquisition system. It's a interface running on Python language. It's very easy to work out, and you can do hundreds of experiments. And this equipment costs only about, this particular interface cost about 2,500 or 3,000. And about 10,000 rupees, any school can set up several experiments in physics, and you can learn science. So I summarize, I end here, and that to ensure a sustainable future poses many challenges. Some of these challenges can be met by researchers in science, followed by development and technology. Nuclear sciences, as I have shown today, I hope I have shown to you that the nuclear sciences provides a unique opportunity to contribute to a sustainable future through understanding the nucleus, and then using the development of new tools, which can go back to the various aspects of society, which is food, health, industry, and energy sources, and as well as education. So there are plenty of exciting opportunities for young persons, and the best brains are required to solve these crises posed by the climate change. And so I hope that some of my young colleagues, young friends who are listening today will be able to take up these new challenges. Thank you very much.
Thank you so much, sir. Thank you so much, sir, for a wonderful lecture. Mainly, you explained how nuclear science and technology is important for sustainable future, and India should be producing more and more energy for providing better living standards for its citizens. And also, nuclear energy is one of the cleanest form of energy, which India should be implementing more and more. Thank you so much for this enlightening lecture, and I'm sure that the students might have enjoyed the story of George D. Hevesy, and they might have got a glimpse of how the scientists implement science in everyday life, especially the nuclear scientists. I'm sure the students got benefited from your lecture. So if the students have got any questions, now they can ask. You can raise your digital hand. Lower right side, there is a handle. You can press that and we will be unmuting you. And now the forum is open for discussions. You can ask in Hindi also, Bengali also, and English also. You may type it in chat box also if you do not have a mic.
I hope it was audible to all of them.
Yes, sir. Yours. Any questions? There is a little hesitation because of the technical, what to say, the distance.
Yes.
So maybe they will get a better chance to interact with you directly once they visit VECC or any of these facilities. You can interact better with the
radioactivity.
Somebody is asking question. There is one question from Dr. Deepak Pandit.
Hello, sir.
Yes.
Hello, sir. Thank you very much for the talk, sir. I just wanted to know what is the current efficiency of the solar cells right now, because nuclear we know it's around 30%. What is the efficiency of solar
it is solar cell. See, the amorphous solar cells which are used in most of the panels are about 15 to 21%. But just about a month back, there has been a report from Golden, Colorado National Renewable Energy Laboratory. They have made a multiple stack of aluminum gallium arsenide and gallium arsenide, a 6-layer stack, which has reached 47.1% efficiency, conversion efficiency. But of course, we do not know how rugged it is and how how it will fare in the open. But it's 47, which is a remarkable achievement.
Yeah.
Yes, there I think I see a question from Atik Ahmed. Question is, if suddenly there is some malfunction in the nuclear plants, then what are the immediate steps taken in order to get control over the radiations? I see if there's a malfunction, there is first of all, in the nuclear plant, the chance of malfunction, there are lots of different layers of safety. So it's not just one particular thing that can malfunction. It has to be a whole lot of things that can malfunction. So there is a first layer of defense, second layer of defense, third layer of defense. Usually 3 layers of things are there. Now so it doesn't normally malfunction, but of course, like one will always cite the case of, for example, Chernobyl, which was a big accident, and then Fukushima, which was another big accident, which has really brought the public opinion against nuclear energy, which has shaped it to a large extent. Let me tell you that in the Chernobyl accident, what happened was they were doing it was actually a human error, not that particular reactor was a very old reactor. It didn't have so many safeguards, first of all. It had only one layer of safeguard, and the people were doing some experiment, and one particular operator forgot, he put the valves, some of the valves he closed in the wrong way, and that's why the loss of coolant was there, and they got melted. At the case of Fukushima, what happened was it was not really a nuclear accident in that sense. It is a tsunami which came and then flooded the entire place. The reactor shut down as expected. What happened was the water came in and shut the diesel generator, the backup power. So after the reactor shut down, also there was some radioactivity will be generated from the radioactive waste products. And that's where that was not being cooled properly because the diesel generators failed. So after this accident, everywhere the reactor design has been altered, and what has been done is that there is a gravity-fed water tanks are always kept near the reactor. So even if the diesel power generator completely goes off, the water coolant will still be there. So it will not be this kind of accidents cannot happen anymore. And as I told you, that if a particular thing malfunctions, there is always some other safety things are there. In the reactor, for example, there is a automatic safety system is there. If suppose the temperature goes up, it's very critically monitored. And then there are there is always control rods in the fission reactors. The control rods absorb the extra neutrons, and so they can shut it down. So this is a auto system which is there, which is kept. in place. So the accident, such kind of accident, the probability of such things has gone down by several thousand times than it was before in the type of, say, Fukushima or the Chernobyl. Because every time something is found out, this entire system is reviewed, and there are very strict guidelines followed by the Atomic Energy Regulatory Board in India and the International Atomic Energy Agency. Yeah, I see another question from Salmik Chakrabarty about the nuclear waste disposal. Yes, as you asked, has there been any significant steps taken towards an efficient and safe disposal method over the world, or is it still in the research phase? There is one, today the steps which are taken is to concentrate some of the waste. See, first of all, we let the very short-lived activity, which is very highly radioactive, decay off by keeping it in a temporary storage first, which is cooled on a 24-hour basis. After that, after a few months or so, when the initial radioactivity level goes down, which was very high, it goes down to some level. Then this radioactivity is taken, you reduce the volume, solidify it, and put it in a glassify it. So this glassified active waste can be disposed of, it can be stored in a mine, deep mine, geological mines, and people are studying that this technique to do it. It has not been implemented fully anywhere yet, because the volume is still not that much. That volume of the waste is not that much to be at the concern, really that much of concern at this moment. But this is a very safe possibility. In geologically stable sites, you can store it. The other one, which is a much more potential, a technological solution, is the transmutation of the waste. And that is in a research phase. And this is done by the very high energy, high intensity accelerator, which are being built, which is not yet built anywhere in the world, but people are building it. In our country, in India also, the Department of Atomic Energy has a program of building a very high intensity proton accelerator, high energy, which will be used for this purpose, for transmutation. So then these radioactive wastes will be the ones which are very active for long-lived ones, like the actinides, will be converted into very short-lived ones, which will then, you have to keep it safe for maybe about 100 years or so, instead of tens of thousands of years in the activity. That part is in the research phase.
Thank you, sir. One question from Dr. Arindam Sikdar.
Yeah.
Hello, sir. I have one question regarding this accelerator mass spectrometry that you have shown.
Yeah.
I have gone through the IUSC site, and I found that they are using only for carbon-14. Is there any specific reason that why it is used only for carbon-14? If one tried to use it for other nucleus, then how much difficult it is? Means, is it possible to go for other nucleus also to do the same?
Yes. No, it can be done for other nuclei. In fact, in IUSC also, there is a carbon-14 is the most widely used one for various radioactive dating, and that can date in the time range of, say, several hundred years to 50,000 years ago. Not very much larger, not very older. Older than 50,000 years, it's not so accurate, because the carbon-14 half-life is only about 5,300 years approximately. So it can go up to 50,000 years back. But there are other radionuclides like beryllium-10 and aluminium-26. These are produced again cosmologically through the cosmic rays, and these are used for dating the rocks for millions of years half-life. So the millions of years, the geological formations are tracked by this. And in the IUSC, actually, they do, there is a facility for doing accelerator mass spectrometry with beryllium-10 and aluminium-26, that is also exists. One can do 36 chlorine accelerator mass spectrometry, and also even heavier ones like xenon and even uranium can be used for accelerator mass spectrometry. But the problem with the heavier nuclei is that you have to take them to higher energy. You need higher energy for that. So to accelerating the heavier particles to higher energy is always more difficult than the lighter particles. There is one question which is that Rishi Banerjee says that I would like to ask how safe it is for people in the vicinity of nuclear reactors and the nuclear plant close to India in Bangladesh border. There's a leak. Will it affect both the countries? Or you can keep ourselves safe from these borderline plants. No, there's no need to be afraid of that, because see, the plants are quite safe. The ones which are now built these days are extremely safe. In fact, the plant for example, there is a reactor in Bombay, which is there are people who are working in Baba Atomic Research Center. They are just about 2 kilometers away from the reactor. So this is not at all a concern in that sense. It is quite safe, and for example, even for earthquakes, they can withstand up to Richter scale 9. That's how the plants are built. So and in fact, even in a normal it will probably require an atomic bomb to really blow up a reactor. Otherwise, it can't be blown up. So that scenario is very, very unlikely to happen, and so there is nothing to be afraid of. The other is I think Anvesha asks, I think, should he opt for clean energy rather than nuclear energy? But see, clean energy, nuclear energy is one of the cleanest energies in that sense. It doesn't warm, because see any technology. Let me put it this way very clearly. I think there are many questions which people are afraid of the nuclear part of it, nuclear energy. The reason it's in the psychology of it has come into our psychology is because we have been acquainted with nuclear power through the bomb at Hiroshima and Nagasaki. It was a very traumatic event, not the peaceful uses of nuclear energy. And that is why there is an element of fear in the minds of people with the radiation. Actually, radiation is not always all that harmful. In that very low level, radiation is present everywhere. We are bombarded with radiation from outer space all the time. If you go for a dental X-ray, you get a lot of radiation. You get a chest X-ray for your diagnosis, we take a lot of radiation. Now the thing is, why we do that still? Because it gives us more benefits. A chest X-ray, if there is a problem with your lungs, you'd rather have the chest X-ray and take the risk of getting a little bit exposure to radiation, because otherwise you might die of other diseases much earlier. So we always weigh the benefits and the risks, and if the benefits outweigh the risks, we take that risk. See, if you can, for example, this is one of my favorite examples is that of a knife, sharp knife. You can use the knife to see, once you form and get a knife, you can use it for killing people or cutting vegetables for you cooking your meal. So it's up to us how to use it. Any technology has its risks.
Thank you so much, sir. I'm sure there will be more questions, but we can take some of them after the debate session. I thank Dr. Amit Roy for a wonderful, beautiful lecture. We shall move on with the debate competition. The topic of the competition is technology rather than science will drive to sustainable future. And if you are aware of the rules, if you are not aware of the rules of debate, I shall say once. First rule, one can speak in Bengali, Hindi or English, and the time limit for the debate is 4 minutes. There will be a warning bell after 3 minutes, and pre-written scripts are not allowed. You are not allowed to speak from reading some scripts. So we shall start the debate, and we have 3 judges here, senior scientists from VECC, Dr. Chandana Bhattacharya, Dr. Sarbajit Pal, and Dr. Shashilal Srivastava. They are eminent scientists from VECC. They will be in the judging panel. So we shall start with the debate. First, I would like to call Shreya Chakrabarty from APJ School. She will speak against the theme.
Ranjani, I will take I will take leave of you.
Yes, sir. Yes, sir. Thank you so much, sir.
Thank you, sir.
Hello, everyone. Thank you so much. The science of today is the technology of tomorrow. Hello, everyone. This is Shreya Chakrabarty of EPT School Salt Lake, and today I will be speaking against the motion technology rather than science will lead India into a sustainable future. The very statement in itself, technology and not science, is very intriguing to me because technology is literally the application of science. Science is investigated. Everything can be explained with science. We have not created science and it was there before us and before everything else. While declaring technology to be more important, we should remember that technology is rooted from science itself. And science is not just any human made philosophy, religion, or political endeavor. It is a method that has boundaries and definitions. Science is required to both build technology and to put it to use. Any amount of lack of scientific knowledge while using certain technological devices can be very harmful. Science is solely responsible for the creation of a certain knowledge base. It becomes increasingly important in the assessment of technology in terms of its wider social and environmental impacts. For example, NASA's lemur took inspiration from a gecko's gravity defying grips. The rows of tiny hairs called setae cling to any surface using the sticky van der Waals force, which only works at a microscopic scales. This was imitated by engineers to make similar setae from silicone. A whale fin turbine imitates a humpback's row of warty ridges, which creates certain tiny vortices that help the fin to cut through the water. The bullet train Kingfisher is a high-speed train based on the Kingfisher beak. This does not only reduce the noise of the train, but also makes it more aerodynamic, which uses less power and enables higher speed. The famous architect Mick Pierce, made termite buildings taking inspiration from termites to construct their mounds with a passive cooling system, using a series of vents along the tops and the sides. For example, the Velcro, the shark skin hulls for ships, it is all made by observing and imitating biology and nature. In other words, science is one of the most important channels of knowledge. It has a specific role as well as a variety of functions which benefits the society. For example, creating new knowledge, improving education, and increasing the quality of our lives. To face sustainable development challenges, governments and citizens alike must understand the language of science and must become scientifically literate. Thank you.
Yeah, but I would like to just comment that reading is strictly not allowed. So next candidate onwards, you may please keep it in mind that you may not read from any scripts. Okay, next, Salmik Chakrabarty from Satishandra Memorial School. He will speak for the theme. Salmik Chakrabarty.
Audio clear?
Salmik Chakrabarty.
Yes, ma'am. Can you hear me, ma'am?
Yes, we can hear you, but your video is off.
Just let me check.
Yes,
Yes, ma'am.
please go ahead.
Good afternoon, teacher. I'm speaking for the topic that technology rather than science will lead India towards a sustainable future. I think this is many aspects. The first aspect that I want to talk about is that in our country like India, which is considered a developing country, the budget that we can invest in science and technology is a very limited. It is limited to the resources that we have. So as for science and technology, we need to find which one is the better investing option. In that case, I think that with the research materials that we have right now, technology will be a better option to invest. Also, that the businessmen, the common people will be more interested in technology than science, because the education in technology or understanding technology or its results for the normal people and even the businessmen, those who want to invest, the immediate results are higher. Technology can give more fruitful results than the research in science in a short period of time within a very limited budget. So this is the main point that I want to highlight, that in our current economic condition, we cannot afford to spend the equal amount in science and technology. But does that mean that we do not need science at all? That's not the case at all. We need sciences, but we need to focus more on technology for a sustainable future. In this point, I think that the developments that we have already made in the fields of science can be used to improve the technology that we have right now. That technology can be given to the common people. Our India is based on agriculture, pisciculture, horticulture, and these can be improved to a huge extent by using technology alone. With the research that we already have, technology can be improved to such an extent that these our agricultural and economic development will be created to a huge extent. Same for businesses. I believe that technology can create businesses while science cannot create business. Science can only facilitate businesses while technology can create businesses. In India, where we are facing a constant problem of unemployment, technology can create jobs. As when we need a business, we obviously need people to run the business. In that case, we can use technology as a source that can create jobs in our country, and science can facilitate that. So with the research that we already have, we can create technology that will improve the economic condition of our country. I think that's why technology rather than science can lead India towards a more sustainable future. Thank you.
Thank you, Salmik. Next candidate, Rita Riddha Karmakar from Satishandra Memorial School. She will speak against the motion. Rita, RHIT.
Ma'am, may I audible? Am I audible,
Yes, you
ma'am?
are audible. Yes, you are audible.
Okay, ma'am.
Please go ahead.
Good morning, ma'am. Myself, Rituridya Karmakar from Satishandra Memorial School. I'm going to speak against the motion and I'm going to speak that science will lead India to a better sustainable future than technology. We know that science actually is the father of technology. That is, without science, technology cannot come. And science has given birth to technology. As we know that science, without science, technology cannot come. And such as the Newton's gravitation law, which is now utilized in many cases, such as in designing lifts, and many other applications are there. And then about electromagnetism, Maxwell's experiments and all those things, because they went into those ventures, and their efforts made us their knowledge which we achieved from science, that only led to the development of technology. And because of those knowledge, and when we apply that knowledge into machines or other forms, we get technology. But if we don't know the knowledge, because science and knowledge is infinite, we can think that the knowledge we are having is enough to build up a better technology, and we can make a better future. But if we use this knowledge, because up to this, if we use only this amount of knowledge, we can't go much ahead. we need to produce, that is, we have to obtain more and more knowledge. So I think that India must invest more on capturing knowledge, that is more on scientific research rather than technology, because technology, India must invest on technology, because technology will lead India to become more developed, to more economically developed. But if it doesn't invest on science, then newer things, newer ideas won't come ahead. Maybe in future we are able to discover time machine and all such things, but that's only because of our ventures into science. Science shows the way and technology moves forward. So without the guide, we cannot move forward. That means without, we need someone, that is science is one who guides technology. Without science, we cannot move forward. As in this past, if we look, then we will come across that it's the science, that is Newton's gravitation law. Then we can come about Einstein's theory of relativity, and several experiments on radioisotopes, and about several many experiments on chemistry, and many such discoveries. Because of those ventures and because of their attempt to go into the depths of knowledge to move forward, that technology was able to follow them and develop our country and the whole world, we can say. So I think that science is very essential, and we need to keep on our ventures into science to develop India for a better and sustainable future. As science can only show us that what is sustainable for us, is how can we find a more sustainable solution for our development of India. So I support that. I'm against the motion, and I support the point that science will lead India to a better and sustainable future rather than technology. Thank you.
Thank you so much. Next candidate, Riddesha De, APJ School, for the motion. Riddesha.
Ma'am, can you hear me?
Yes, you are audible. Yes.
A very good evening, everyone. I am Riddesha De of APJ School, Salt Lake, and I'll be speaking for the motion on the topic technology rather than science will drive India to a sustainable future. Technology is the practical implementation of theoretical science.
Riddesha, can you please speak little louder?
Ma'am, am I not audible?
Yes, no.
Ma'am, is it fine now?
Yeah, okay. Carry on.
As I was saying, technology is the practical implementation of theoretical science. Our lives have drastically changed in the last few decades due to technology. All around us, we are surrounded with gadgets like smartphones, virtual personal assistants like Alexa, Siri, Google Home, smart TVs, internet, social media platforms, and whatnot. And all this is a result of technology. Technology has reduced human effort. It has increased the efficiency and productivity in every field out there. It has made our lives easier and much more comfortable. It has made breakthroughs and innovations in almost every field. We can now communicate with people all across the globe with the help of social media platforms, audio conferencing, video conferencing, texting, etc. Technology has also increased the efficiency and flexibility in workspaces. Internal and external communications have become much easier with the help of emails. Automation has reduced human effort, and all this has led to the increase of employee productivity. Technology has also greatly influenced the field of education. Students can now access information and resources from multiple websites from the internet. Teachers can teach students from anywhere across the globe. The current pandemic situation is a living example of that. Nowadays, artificial intelligence and machine learning techniques are being used to build robots, which can help medical experts in organ transplants, surgery, brain mapping. It can help astronauts to survive in zero gravity. It can help in space exploration. It can help us in building smart cities, smart homes. It can help us in manufacturing tools for agriculture, expedition, and many more projects. All these examples clearly indicate that technology can find the potential in existing as well as upcoming projects. And this will not only lead India, but the entire world to a sustainable future. Science is the backbone of technology. A backbone is indeed a very crucial organ for a functioning body. But without the body functioning, there is no use of the backbone. Without technology, science is just information written in a piece of paper. Thank you.
Thank you, Riddesha. Next candidate, Paulomi Guho from APJ School.
Yes, ma'am. Am I audible?
Yes. You will speak the motion. You will speak against the motion.
Yes, ma'am. Good afternoon, everybody. I'm Paula Guha of Class 9, APG School, Salt Lake. And today I disagree with the previous speaker. So I'm going to speak against the motion. Science is the root of technology. No scientific development means no technological advancement. So some of the most significant scientific and technological inventions were AI, electricity, semiconductors, and VRs or virtual reality, etc. Technology is a mechanical copy of nature. For example, robotic hands used during operations replicate humans' hands. This was first used in June 1997. Nuclear submarines such as INS Arihant used for India's defense resembles the streamlined shape of fishes. The first design of airplane drawn by Leonardo da Vinci in 1490 approximately looked like a bird, which was later developed by the Wright brothers. While science is the bridge between nature and technology, the development of science to technology is research. We can give examples from two major fields in which India has excelled: nuclear power and space science. Ernest Rutherford discovered the nucleus of an atom through his alpha particle experiment using gold foil in 1911. After 43 years of continuous research and development, the first nuclear power plant was founded in Omsk near Moscow. And yet another 3 years were spent for R&D by India to inaugurate its first power plant, Apsara, by our president, our Prime Minister Jawaharlal Nehru. Today, the world has advanced to a height where thorium-based third-stage nuclear power programs like Kármán test reactors are being used. Science has made India competent to contribute to ITER. Aryabhatta, the greatest mathematician and astronomer of India from 1499 AD, explained solar eclipse, lunar eclipse, and the rotation of Earth on its axis through his spherical geometry. And only after 15,000 years later, his thoughts were cultured and his ideologies helped India launch its first artificial satellite, Aryabhatta, on 19th April 1975. With research and development in science, space science, Isro's director has officially declared India capable of making itself a self-built space station of 20 tons. Isro holds 5th position in the world ranking as of 2022 and has achieved this through missions like MOM, Chandrayaan 1, etc. A sustainable future can be achieved only when we use economy, human resource, and the environment in a balanced proportion. Human resources developed through health and education, which cannot be single-handedly handled by technology. Chanak and Suter marked the golden age of Indian medicines from 1800 BC till 1000 CE. Their discoveries were widely discussed, which led to a world in 1967 where first successful heart transplant was done. Technology also can lose its shine after a certain period of time. Today, technology has a huge market price. That is because every day something is being updated, and this update is science is only capable for this update. If supply is high and the population is the same, this leads to a decrease in the demand, and the economy fails over time. Our country's safety is related to science too. Scientists in DRDO have come up with ICBMs, intercontinental ballistic missiles like Agni 5.
Your time is coming up.
Okay, ma'am. Several warheads and I'm almost completed. I'll just complete everything.
Yes.
And hide crafts like Tejas, which give us peace of mind saying that we are safe. This topic can be discussed in a yet broader form, but I would like to conclude here saying that technology can help in a sustainable future only when there is development, and this development comes from continuous scientific research. Thank you.
Thank you, Paulomi. Next candidate, Vaibhav Bhaskar from St. Xavier's Collegiate School for the motion.
Hello.
Video is You're audible. Yeah, visible also.
So, shall I start speaking now?
Yes, please. Vaibhav, you can speak now. You are not audible.
Yeah, suddenly I just muted myself.
Now you are audible. Yeah, please carry on.
So, a very good evening, everyone. And today I'll be speaking for the motion that is technology rather than science can lead to a sustainable future. So, the English dictionary defines as technology as the everyday application of science to solve various problems. Truth be spoken, today's age needs more problem solving than discoveries. Be it global warming, food shortages, from energy production, renewable clean solar energy production, or using less fuels to send up rockets up into space, all we need is to solve such problems. It will be correct to hunch that technology will be the redeemer in the future days to come. Difference should be noted between types of problems and kinds of problems, in sense that science in general caters to different types of problems, whereas technology generally caters to different kinds of problems. If one keeps his eye open, he will surely notice the world is devoting itself to solving difficult kinds of problems, ranging from forest fire protection to earthquake-proof buildings, hyperloop concepts, digital spectacles, new age cell phones, to frictionless shoes, and so many. The level of problem solving skills that we need are just unending. Science, as it were, is there, but technology is there to reciprocate scientific funders and theorems to common people who otherwise have little knowledge to understand these concepts, especially in a country like India, where the majority of the population doesn't even pass the fifth standard of education in school. When technology, another point to note is when technology invents a gadget, be it a cell phone, a new cell phone, your new age drones.
Vaibhav, you have 1 more minute.
Okay, I'll finish it quickly. Be it cell phones, drones, or all the way up to quasar detectors, it does so within a short time. However, with science, the same cannot be said, because it is seen that to generalize theorems and statements and to make discoveries, it often takes years to do so, as with many infamous scientists. Science, as it were, has idealized statements and theorems. It is the responsibility of technology to move these theorems forward. Throughout past centuries, infamous scientists and philosophers like Galileo, Aristotle, to as recent as Stephen Hawking, have been making discourses and discoveries to make human lives better and more independent. They have turned the wheel of science, and I
Vaibhav,
believe.
time is up.
Okay, I just have one more line.
Yeah.
And I truly believe it is the duty of us to turn the wheel of technology, without further damaging our surroundings, and to bring about good days effortlessly with technology's help. So here I conclude my speech saying that technology is, of course, far more in the sense a redeemer than science itself. Thank you very much.
Thank you. Next candidate, Roshni Prasad from Satishandra Memorial School. She will speak against the motion. Roshni Prasad.
Good afternoon, ma'am.
Yes, please carry on. You are not visible. Please switch on the video.
Ma'am, am I visible?
Yeah, can you tilt the camera? Okay, go ahead maybe. Roshni, you can speak
Yes.
now.
Good afternoon, all. I'm Roshni Prasad from Satishandra Memorial School, and today I'm going to speak against the motion. Technology rather than science, it will lead to a sustainable future.
Roshni, you want to continue?
Yes, ma'am.
Yeah, please don't worry. Don't get nervous. And it's okay.
We can come after later at the end.
Or we can, or if you want, we can come back to you like a little later.
Yes, a little later.
Okay, that's fine.
Okay,
Thank
fine, Roshni. Next candidate, Rashi Banerjee from APJ School for the motion.
Yes, ma'am.
Rashi, please. Yeah, fine.
Am I audible?
Yes, please go ahead.
You know, every year we used to go to go on a science day field trip to the institution. We used to see all the equipments. We used to talk to the scientists, the teachers. We used to see everything with our eyes. We used to see all the equipments, and we even had the debates, everything one-on-one in a physical form. But comes in the COVID-19, drives us all away. We have everything indoors. We can't go anywhere, visit anything. But the question arises that is it stopping us from doing anything? I mean, we're still having this Science Day celebration. We are still visiting the institution, literally. We are still talking. We're still having this debate. And that is all because of technology. That is all because we can see, we have this technology with us. That is all because of virtual reality and augmented reality. Good afternoon, everybody. My name is Rashi Banerjee. I'm from EPJ School, Salt Lake, and I am going to speak for the motion, which is technology rather than science is what will drive India towards a sustainable future. Technology is the future. Technology has brought this whole world at our fingertips. Let's talk about the Ukraine-Russian war, for instance. We know every detail about what is going on in the war, what is happening right now, or what happened before, everything, and it's traveling to us so fast. It didn't happen during the World War I or World War II. It's happening now. Why? Because we have upgraded technology. Why? Because talk about the common people, for instance. The common people, we can know their thoughts, we can know their point of views, we get to know what is happening to them or what they are going through, and that is happening in the fraction of speed because of technology. Well, talk about transportation, for instance, and take the example of Ukraine-Russian war. Well, the foreigners in this Ukraine-Russian war who are not in their homeland can travel back to their homeland or communicate with their families. And that is because of the upgraded technology. That is what technology has done to us. Well, we have other things like the drones, the robots, which are the drone, the flying robots that are helping us with starting from law enforcement to security and safety. Well, going back to the transportation, we have Hyperloop, where it travels in the speed of light. Well, talking about pollution control, we have electric cars coming up. And that is a great way for a sustainable future if we are talking about. We have swarm drones which is helping the armies with more surveillance capabilities. And then we have the actual AI physical robots. And well, for example, how it's helping us is, let's talk about the nuclear plant safety measures, or let's say there's a radioactive situation going on. Well, if it can be deadly or fatal to mankind or to humans, but if it's a robot we are sending, then it is much easier for a robot to go and
Rashi, you have 30 seconds.
right. So that is how it's helping us. Talking about job opportunities, we have so many new opportunities coming us, UX designers, robotic engineers, cloud engineers, and so much more. And it is estimated that by 2025, we will have 12 million more opportunities for this. And then, well, technology comes to the market. Technology is what sells. I wouldn't want to know how a washing machine works, but I would want to know whether it's cleaning my clothes or not. I wouldn't want to know how Siri works, but I want to know my answers, which I'm doubted about. Well, Stephen Hawking, for instance, he used, when he lost his speech or his verbal consults, he used speech detecting technology and his wheelchair, and used the computer in his wheelchair. It used infrared sound to.
Rashi, your time is up. You took 25 seconds more. You just conclude.
Okay. It used his cheek movements to help him, help us understand him. So that is how deep technology is going, and that's how sustainable it will be for us Indians in the future, or for the whole world in general. And that's how I would conclude my speech. Thank you.
Thank you, Rashi. Next candidate, Anvesh Mukhopadhyay from St. Xavier's Institution, against the motion.
Hello, ma'am. Am I audible?
You're audible. Your video. Please switch on the video. Yes. Please carry on.
Good afternoon, ma'am, and everyone. I am Anvesh Mukhopadhyay, studying VECC, St. Xavier's Institution, Panihati. Today, I am going to say against the topic. Science is like the brilliant thoughts of our mind, but technology is the real-life execution of those thoughts. Technology is the material manifestation of pre-existing scientific knowledge. Science is the study of materials of nature that the materials build of. We see a plant photosynthesize. It is a technology that the plant uses. But behind that technology is a science, the science of chemical reaction and energy absorption. If we go and break it down to the very atomic level, we see that the atoms too use certain kind of technology. The electrons revolving around the nucleus, the attraction, the repulsion. So science and technology are extremely correlated. For betterment of the humanity, science and technology can be used in various fields like agriculture, space, defense, military, etc. For agriculture, for better yield of crops, we can use certain methods like tissue culture, artificial pollination, GMO, or better breeds, cross breeds for better crop production. We can use satellites to plot and allot lands. Also, in recent years, there are agro-based robots which are used for harvesting, seeding, planting, etc. For stopping the use of fossil fuels, we are using clean source of energies or clean energies like the solar energy, wind energy, etc. India's first and world's first solar powered airport is India's Cochin Airport, and India's first railway station is Guwahati Airport. We are also proud that India ranks among third in the world as the producer of clean source of energy. ISRO, Indian Space Research Organization, is ranking among the top 10 space research organization of the world. It has produced many rockets and satellites that has helped the world, like PSLV, GSLV, and the famous Mangalyaan satellite that's going all over the Mars. That was produced with a lower and economic budget than a Hollywood movie. Science and technology are extremely correlated. If we use them, our humanity can proceed much better, and we can delve deep into the understanding of knowledge, and it will be better for us, our nation, and humanity. Thank you.
Thank you, Anvesh. Next candidate, Trisanjit Das from Benpur Riverside School for the motion. Trisanjit Das. Trisanjit Das. No, you are not audible. You could just see the chat. Please switch on the video and audio. If you are unable to, then we can call the next candidate and you can come later. Okay, Trisanjit. We shall move on to the next candidate, Shantanu Datta, Satishandra Memorial School, against the motion. Trisanjit can be ready. Now it is Shantanu Datta.
Oh, beforehand you haven't done, that's why.
Excuse me, is my audio audible?
You are audible. Please switch on the
Okay.
video.
Oh. Yes. So, yes. So, good afternoon, everyone present over here. I am Shantanu Datta of class 12 from Satishandra Memorial School, Chagda, and I would like to speak against the motion technology rather than science would drive India to a sustainable future. So my first thing is that when we are talking about sustainable development, we are it refers to such kind of development where we will get development in the present stage, means in the present day, without compromising the needs of the future, right? Now, for this kind of goal, we would require technology, and for technology, we would require science, because science is the guide for the technology. So if we are asking about technology without science, it is like we are asking about we want to drive a car without a wheel. Okay, so it is impossible to imagine technology without science, and it is my belief that without first we have to consider about science, and then we can think about technology. And I have many historical examples also to prove this point. First thing I would like to mention about electromagnetic spectrum, right? So the study of electromagnetic spectrum actually in those times there was nothing called electromagnetic spectrum only. Electricity and magnetism were totally two different aspects of science, and as we have read, many famous scientists such as Alessandro Volta, and then there is Coulomb, and many others. They started this field, right? So they started with electrodynamics. I mean electrostatics. Sorry. So they started with electrostatics, and slowly they started to explore this subject more purely to quench the thirst of human curiosity. Their goal was not to make technology; it was to understand the nature. Now, because of this kind of study, we later see in the history that electricity and magnetism are related. And then Maxwell put forward those four equations of um, electromagnetism, right, which describes the entire field. Now, what is that? Now, what we have got from this from this long research, we have got electromagnetic spectrum. Now, in this electromagnetic spectrum, there is radio waves, and radio waves are used. Radio waves has facilitated mass communication, right? Means to spread information exchange. It has facilitated information exchange. Then if we talk about the far end of the
Shantanu, you have one
electromagnetic
more
spectrum.
minute.
Okay.
You have one more minute.
Okay. So the second thing is if we so like this, it has facilitated mass communication. Second thing I would like to mention about Alan Turing. So because of him, he gave the the concept of Turing machine purely to solve an abstract mathematical problem. But because of that theory, computers were developed. Similar and today I am able to speak to you I am able to speak to you because of that technology only, and which came from Alan Turing himself. So another thing I would like to point out that like Salmik Chakrabarty, I guess he pointed out that India in this current state of economy, it is more fruitful to invest only in technology. But I would like to point out that even Japan, just after Second World War, they were also in a dire state, right? But they instead first invested on basic research, and because of that basic research, today it is bearing all the fruits. We can see that Panasonic, then there is
Shantanu,
Sony,
your time is
etc.
up.
Okay. So I would like to conclude by saying the thing that technology cannot come from thin air. We have to first invest in basic sciences, and then technology will get automatically developed from it. Thank you.
Thank you, Shantanu. We shall call Trisanjit Das once again. Trisanjit Das from Burnpur Riverside School for the motion. Yes, you are visible now. Can you speak? You are not audible. Please unmute yourself. Yeah. Okay. Then we shall call you later. We will move on to the next candidate. Trisanjit, we will call you later. Next candidate, Shubhamita Ghosh from Burnpur Riverside School for the motion.
Yes, ma'am. Am I audible?
Yes, you are audible. Please switch on the video.
Yes, ma'am. Ma'am,
you are
audible,
audible,
am I
but
visible?
Yes, you are visible. Please carry on.
Yes, ma'am. Good morning. Good evening, respected one and all present here. I, Shubhamita, today going to speak for them. Just what happened? Yes, ma'am. I'm starting from the beginning. Good morning.
Can you please switch on the video?
Respected one and all present here. I, Shubhamita, would like to speak for them. Just what happened? Yes, ma'am. I'm starting from the beginning. Good morning, respected one and all present here. I, Shubhamita, would like to speak for them. Just what happened? Yes, ma'am. I'm starting from the beginning. Good morning, respected one and all present here. I, Shubhamita, would like to speak for them. Just what happened? Yes, ma'am. I'm starting from the beginning. Good morning, respected one and all present here. I, Shubhamita, would like to speak for them. Just what happened? Yes, ma'am. I'm starting from the beginning. Good morning, respected one and all present here. I, Shubhamita, would like to speak for them. Just what happened? Yes, ma'am. I'm starting from the beginning. Good morning, respected one and all present here. I, Shubhamita, would like to speak for them. Just what happened? Yes, ma'am. I'm starting from the beginning. Good morning, respected one and all present here. I, Shubhamita, would like to speak for respected one and all present here. I, Shubhamita Ghosh from Bonpur.
There is some
Ma'am, I have
disturbance in
turned
the
on my video.
connection.
What is happening?
There is some network issue. Shubhamita, we shall call you later. Next candidate, Suhani Goswami from Burnpur Riverside School against the motion.
So we can.
Yes, ma'am, can you hear me?
Yes, we can hear you.
Okay, ma'am. Am I visible?
You are not visible. Please switch on the video. I think video on करने से गड़बड़ हो.
It's better to off the video.
Ma'am, am I visible now?
You are not. You have some network issue there, then you can carry on with the video off.
Okay, ma'am. Yeah, I'm having some network issue actually.
Okay.
Okay, ma'am. Good evening, one and all present here. I'm Suhani Goswami from Banpur Riverside School, class 9. I'm going to speak for against the motion. So we have learned from this life that everything found on Earth has both its pros and cons simultaneously. Thus, we cannot deny the fact that technology has a big impact on us, like using the automation to shut down the unused electronic devices. For example, when we shut down the computer or laptop, our computer system will stop the memory hog from causing the problems and thus give us a smoother and faster experience. Wi-Fi is great, but sometimes it just does not work how many times we run the diagnostic tool. With the increase in technology, the radioactivity also increases, which causes the harmful rays like alpha, beta, and gamma rays to spread in the community and cause various health effects on human beings. Though sometimes these rays are useful, but it can cause more damage to our body. For example, when we use the cobalt 60 gamma rays for the detection and treatment of cancer, it enters into our body and damages the cancer cell of our body. But if it enters the undamaged cell of our body, it will damage it and our body will not be able to function properly. Now, using multiple social media platforms like the Facebook, Instagram, Snapchat, etc., people are getting more addicted to this rather than spending the quality time with their friends, families, neighbors. Both the youngsters and adults are busy in internet surfing, playing video games, and therefore they're ignoring their real life. Sometimes the overuse and overexploitation of these apps can lead to the data leakage and hijacking, which can expose our personal information to any unknown person, and they can make misuse of this information. Now, cryptocurrency run on a distributed public ledger called blockchain, which is a record of all the transactions updated and held by currency holders. But when we use multiple devices to maintain this, it can cause lagging and we can lose all our savings. Moreover, expenses associated with the development,
Suhani, you
acquisition.
have 1 more minute.
Okay, ma'am, I will complete. Moreover, expenses associated with the development, acquisition, implementation, deployment, maintenance of asset of technology that includes
depreciation and amortization. It cost efficient. I would like to end my speech by saying that the most important thing is that people are becoming lazy day by day. The capability of doing work decreases with the increase in technology, and thus we should take a control of it. Thank you.
Thank you, Suhani. Next candidate, Aratrika Paul from Burnpur Riverside, against the motion. There is an announcement for the participants. We shall be sending registration kit to the registered participants. So you may please write your name and the postal address in the chat box. All the registered participants are requested to type the name and the postal address in the chat box. Okay, you must send your residential postal address. Aratrika, are you ready?
Yes, ma'am. Am I audible?
Yes, you are audible. Please switch on the video.
Yeah, yes, ma'am. Am I visible now?
You are not visible.
Ma'am, 1 minute. Yes, ma'am. Now can you see me?
You are not visible. Aritrika, you may go ahead.
Yes, ma'am. I'm starting my speech. Yes. Good evening to everyone present here. I am Aratrika Paul from Banpur Riverside School, Chitranjan, and I would like to speak against the topic that is technology, science and technology for sustainable development. As we all know, science is rather technology can lead us to better sustainable future. But increasing in technology can also lead to harmful effects, just as if we use so much of social media platforms like Facebook, Instagrams, WhatsApps, then it is causing addiction to us. We are always using these apps and not focusing on other things, that is our studies or our spending, or with not spending time with our family members or friends. Children are getting addicted to video games like Free Fires and PUBG, many games, and they are not able to focus on their studies, and this can cause effect to their final results of the studies. Moreover, the increase in radioactivity can lead to many harmful effects. For example, the cobalt 60 rays, which are used for the treatment of cancer, which finds the infected cell and effect and damages it. If it falls on the any other cell of the body that is pure and healthy, then it can cause any malfunctioning of the body. With technology is very much helpful, we know, but sometimes uh, with increase in technology it leads to in leakage of data or hijacking. Improvement in science and technology can also lead to better future. For example, in case of agriculture, the HIV seeds and new irrigation systems are very much helpful for the future programs.
Aratrika, you there?
Aratrika? We are not able to hear you. Aratrika is there? So we shall call the next participant, Roshni Prasad, Satishandra Memorial School.
Ma'am, can you hear me?
Yes, please switch on the video.
Ma'am,
Yes,
is it okay?
Roshni.
Good evening, all. I'm Roshni Prasad from Satishandra Memorial School, Class 8. And today I want to stand before to express my views against the motion technology rather than science will drive India towards a sustainable future. In today's world, sustainable development, it has been a key aspect of development, and it refers to the development in a manner which does not compromise the needs of the future. For example, we can take the instead of non-renewable resources like coal, petroleum, we are always advised to use the renewable resources of energy. So it is evident that we are always that we require new, efficient, and affordable technology to achieve this goal. And it is my belief that before development of any kind of technology, the science behind it must be known effectively. Design that a new take. Historically, this principle, sorry for the interruption. So historically, these principles of science were discovered beforehand purely to quench the thirst of human curiosity. And saying that technology without science is like, I want to, like a tree, saying that, that saying technology without science, it is like a saying that I want to drive a car without wheels. So I would like to start with the father of physics himself, that's Sir Isaac Newton. He gave the laws of motion and then the theory of gravity with the methods of circulating changes in system, that is the calculus. He gave these theories purely for the sake of studying it. The laws of motion along with some other theories, it defines the vast field of mechanics and mechanics with which help us to construct the massive structures, says we can say that bridges, then buildings, etc., in an efficient manner. So theory of gravitation is just bread and butter for the development of space technology, like satellites, which are in turn helping us in the communication. Speaking of communication, it would be injustice that if I don't mention about the study of electromagnetism. Study of electricity started with an attempt to explain some natural phenomena, and like lightning or discharge due to the static charges. So thank you.
Thank you, Roshni. Next candidate, Trisanjit Das once again, Banpur Riverside School. You are visible now. You are not audible. You try switching off the video and try to speak. Oven. It's like technology is not supporting Trisanjit Das. So we shall call Shubhamita Ghosh. Trisanjit Das, you have one more chance. You can keep trying. We shall call now Shubhamita Ghosh from Burnpur Riverside School for the motion.
Ma'am, am I audible?
Yes, you are audible. Please switch on the video.
Yes, ma'am.
Shubhamita Ghosh.
Ma'am, am I visible?
Shubhamita.
Yes,
Yes.
you are.
Yes,
You are
ma'am.
visible.
Thank you. Yes, ma'am. So I'm starting my speech. Amita Ghosh, today here to from Banpur Riverside
Shubhamita,
School.
sorry
Today
to
here to
Shubhamita,
yes, ma'am.
sorry to interrupt you. You may switch off the video and
Ma'am,
speak. There is a network
yes,
issue.
ma'am. Actually, my video is getting turned off automatically.
You can keep it off and speak.
Okay, okay. Thank you, ma'am. Thank you, ma'am. Requested one officer. I Shubhamita Ghosh from Banpur Riverside School, Chittaranjan, class 9, and today I am going to speak for the motion. Now, yes, obviously, technology rather than science can lead us to sustainable futures. Yes. Now, this current generation highly uses technology in various sectors in their day-to-day life. It is the knowledge that helps us to create and invent new ways, devices, and various machines that facilitate human beings. Also, we can say that now this arrival of various machines and devices has made our life much more easier. Now, it is also a boon for us. We must consider it as a boon. Now, let me now go to the various ways by which we use technology in our day-to-day life. First, I come to the communication. Now, in the field of communication in ancient times, one simple information in the form of postcard, it needed much more time to reach the people, and it was also cost was also spent by the people. But now in this current world, we see that internet has led us to the internet is used by the people, and we can send our information much more quickly. Email is there, and various social media is also there, various chat apps are also there. So with that, we can very easily send our information very quickly, and it takes just milliseconds, and it is also cost is also less in that. Now, next I come to the home appliances. Now, this current generation is very busy in their work. So this technology, it reduces the time. It reduces our time, and it makes our work also easier. So various home appliances for cooking food, for washing our clothes, and various other things in our day-to-day life, we use the home appliances also highly. Now, next I come to the medical field. Now, also in the medical field, with the development of the technology, the treatment of the people is also done very much efficiently, and we get just successful results. Now, next I come to the transport. Now, in transport also, for transporting various articles from one place to other, we use technology. It is also used there. And so I conclude by saying this, that technology is highly used by us in our day-to-day life. So the development of this technology, it will lead us to sustainable futures. Thank you.
Thank you, Shubhamita. Trisanjit would like to try once again. Trisanjit Das from Banpur Riverside School. Okay, so since there is no response, we shall conclude the debate session here. We are very happy to see the enthusiasm you have shown in participating in the debate, and congratulations and all the best for all the participants. Yeah. So one of the judge will make a few comments or observations. We shall listen to him, Dr. Shashilal Srivastava.
So, hello everyone, and so I am Shashi, and it was really a pleasure listening you all for last about 1 hour, and got to know a number of interesting facts that how people think about how to go about science or technology or which is the way forward. So some of the things that the kids pointed out was like how technology is yesteryear's science, and how if we want to keep updating in terms of technology, then we have to do new and newer science every day. So that was a very, very nice point and well made. And again, I am not taking names of the participants who said what, but it was interesting to think that you are very well aware that technology on one hand is making our life very, very simple, solves day-to-day problem, sometimes medical, sometimes daily chorus, but at the same time, it is addictive as well. So, and some of you pointed out about social media very rightly. And communication for once was very, very nice example have been given by some of the participants, and very interesting, very, very nice. And thank you all. And we look forward you all sometimes here in our campus to meet you in person and discuss things and talk to you all. And with this, I wish you all a very, very bright future. And now we will, in few minutes, we will tell you about our results. Right? Okay. Thank you. Thanks.
Thank you, Dr. Shashi. Thanks to all the participants who has participated in the debate. If you have any more questions, you can type in the chat box.
We'll go to my room.
Sir, should we fully this question? This one. Annesh Mukhopadhyay. Sir, should we fully off clean energy rather than nuclear energy, since it is less harmful and does not produce harmful nuclear waste? Oh, I have to go there.
Requirement is so high that
Animesh Mukhopadhyay, should we opt for clean energy rather than nuclear energy? I think nuclear energy is also a clean energy. I think Professor Amit Roy has explained in his slide also, comparing with fossil fuel energies and other actually. Even indirect also, pollution is very much less actually. If you have seen his bar chart, actually, if you remember, actually has clearly explained already. See, cobalt 60 is actually high specific activity and then can be easily produced in the reactor, and it is having a high energy. So nowadays cobalt 60 is being less used actually. Earlier for teletherapy applications, actually cobalt 60 is used because of its mean energy, high gamma mean energy is about 1.25 MeV actually, which is very ideal for teletherapy application. That's why cobalt 60 is used for radiotherapy.
In future, does we use uranium in critical cancer treatment? In critical cancer treatment.
Uranium is not used for cancer treatment.
Okay, that's all from the earlier session. Yes, if you are talking of nuclear energy, which depends on various radioactive elements, are we not prone to drain the stock of such elements, causing a paradox? From Trisanjit Das.
Good waste, I think. I think Professor Amit Roy has cleared in his previous sessions also. Actually, in the question answer sessions, he has answered it actually. How safely these radioactive wastes are disposed and then stored in a trenches after vitrification, glass vitrification, and other he has explained already.
Saying that it will end up someday, but the deposit is so high that it will take quite a long time. Moreover, there is large amount of thorium-based lot of work need to be done there, and then it takes a long time to exploit all the currently. So not need to worry for next maybe 100.
Acha, he is talking about stock.
No, he is saying that it will end up someday, so there will be no more.
Yeah, we are going for 3-tier program, and other actually, if you use that 3-tier program, actually this thorium based actually for production, actually we can run for another more than 300 years.
You can type in the chat box.
We'll be happy to help you.
And also, as Dr. Shashi suggested, that you all should come and visit our center once, and then you can interact directly with the scientists over here.
And can see all the facilities over here.
You can see all the facilities here. In VECC website, there is a public awareness cell. There you can get the application where you can apply for coming to VECC and have a half-day program here. And you can specially mention if you would like to see any particular facility here. Otherwise, we have a few options that you can choose, and then you can come and participate. Yeah, that will be very nice to meet you in person.
Actually, there are hazards connected with any energy production, including coal also, you have fly ash and other things. But for nuclear energy, not only in India, throughout the world, actually globally, enormous amount of safety procedures have been implemented. In India, we follow defense in depth, redundancy and all that. So it is quite safe. We are operating many decades actually, these nuclear power plants without any major problems. Actually, even whatever any troubles or defects and other, actually they are rectified and other without causing any harm or any release of radioactive material to radioactivity to the environment. So by taking the proper steps, actually safety measures, actually nuclear energy production means energy production through nuclear is very, very safe.
So now
This is the moment you are waiting for.
This is the moment you are waiting for. So I request Dr. Shashilal Srivastava to announce the winners for the debate participation. Dr. Shashilal Srivastava.
Okay, let me from the very outset kind of confess that it was a very, very tight decision, and we really heard a number of good points from various people, and it was really nice to listen all that. But as is the process, and so we have our first three, and the third position was obtained by Ms. Rashi Banerjee from PJ School. Second was for Ms. Paulomi Guho from PJ School again. And the first prize goes to Mr. Shantanu Datta from Satishandra Memorial School. So these are the first three for today. And we congratulate all of you. Thanks.
Congratulations to all the winners. And those who didn't win, you don't need to feel bad. You have really done a wonderful job. And some of you have even participated from the remote distance with a lot of difficulty and even in technical issues. So we really appreciate that. And all the best for all of you. And once again, we would like to invite you to visit our center. You may just drop a mail or through the process what I have explained earlier, you can apply to come and visit our center. Thank you so much for the participation. So here we conclude the session today. Thanks to all the members and special thanks to the judges and also the wonderful speaker today. So we have small memento for the judges. So we shall hand over the mementos. I would like to invite Dr. R. Ravishankar, Head Health Physics Section, to hand over the prize to Dr. Chandana Bhattacharya. Thank you so much, madam. I would like to request Mr. Partho Bhaskar to hand over the prize memento to Dr. Shashilal Srivastava. Thank you, Dr. Shashi, and thank you. And Dr. Sarvajit Pal is not here right now. He has gone out for some emergency work. So we shall hand over that memento to him. Thanks all for the participation and see you soon sometime. Thanks.
Thanks.
Thanks for Ranjani conducting the meeting.
Thank you so much.